on his skis.
Yeah, true too. Or the sci-fi.
Yeah.
So why would he even have a boat in the first place if they're the same speed as
Well, because the little motor does not work forever.
What's that quantity? I'm serious, I don't know.
Oh, we converted 30 meters per second, 80 per second, so we could actually get answer.
But they gave us.
That's the velocity.
That was the rate that he's giving to the right.
They gave us the original rate in meters, and so since everything else is measured in feet, we changed it to feet.
But I don't understand.
Yeah, well, look, we don't have the problem here. This could waste class time. We need to do chapter.
No, actually, just for another 60 seconds. What did this represent?
That's 30 meters per second.
No, what in the pictures are represent?
Oh, the velocity that he's moving at.
His rate going that way.
Oh, so that's the rate at which he's going up.
Yeah,
right?
yeah.
Yes.
Right?
Yeah.
No,
No, it's not.
that's not him going horizontal.
Yeah, I think you're going to have to come up with this by using a bit of trigonometry.
Oh.
Yeah, I think that's much more complex of a question. Because that's the rate at which he's being pulled forward, then shoot, once he hits that ramp, boom, I think that rate's going to change.
But wouldn't that affect whether he's holding on to it or not?
True, but they said he was. They said he's holding on to the very
If
end.
he is, then he's still going at a constant speed if the boat is going at a constant speed.
True, but it's not the same constant speed as my That is a much more complex. Where'd you guys get this anyway? That's a good question.
It's out of the book.
Is it really?
Stewart.
Oh, Stewart.
But they don't have control.
Yes.
Incorporating gravity here? What's the mass of the skier?
No, I don't have to, only because the rate of change of his position horizontally is given. And, by the way, what he's saying, Reese's saying, is important if I talk about after he was released. Then I have to take into consideration that gravity. But because you're talking about the rate at which you just left us, that's different. Yeah. Good question. I like that.
So how do we?
No, I can't take time tonight. I've got two big topics I want to discuss.
Is something that crazy going to be on the test?
No.
What's your definition of crazy?
That.
Something that time consuming.
Oh yeah, I have a question. How many related rate problems do you think you're going to be putting on the exam? Do you have an idea?
Yes. Emphatically, no more than two.
Two?
I said no more than two. It takes so much time. So.
Well, that and then the max and the mins and then all the other things. That's.
Oh yeah.
So can we expect anything like that trough problem? That.
The trough problem wasn't that big of a deal.
Okay.
Yeah.
You're going to get
It was a very big deal, actually.
No. It wasn't.
Yes.
We're not going to.
It took 3 boards.
We're gonna go what?
We're not going to. We're not talking about the trapezoidal trough we were looking at earlier.
Oh, the trapezoidal trough
Trapezoidal,
is nice.
circular.
Yeah.
Oh, they're all the same.
They'll all fail you.
Yeah.
Don't say it that way. You're such a pessimist.
When it comes to troughs, yes.
So you don't like troughs?
No. Especially doing math with troughs.
That's going to be applied to everything.
Test on what? What? Very good. Oh, you guys, am I really that limited? There's only. No, there isn't. Hold on. Actually, we're littering all over the floor.
Actually, no, it might be better.
Nothing more, nothing less.
So you guys, let's take this to the next level. Last time you and I discussed, we talked about the first derivative test, the second derivative test. We talked about how to determine whether or not we got local extrema, how to find inflection points. We even discussed how to determine whether or not a function was increasing, decreasing, or concave up or concave down over certain intervals. So if you guys don't mind tonight, among other things, what I want to do is put things together. So, question. Let's see if you and I can't graph this equation. And before I apply any of my tools of calculus, I'd like to kick back in the time I pulled my tools of math, yeah, your favorite math class. In Math B.
So you plot points.
Yes. Well, special points. If you were to factor this right-hand side, what would you get?
X squared to 2x minus 3.
Well, isn't it like a term?
I gotta think about it a second.
No, you said it right. You said x squared times 2x minus 3. So -4, you guys help me with this.
Six.
What color do you prefer? Do you prefer green or blue?
6.
Purple.
Thank you.
You're welcome.
Neither. Because when you pull out a -4, here's what's up to it.
6. Sorry.
My apologies. You're right. I'm wrong. I was just listening. My apologies. Got
Wish
it.
it was a 4.
2x minus 3.
Very nice. Why am I going for all this garbage?
Well, give us our critical points.
I'm factoring. How do I factor further?
X squared minus 6.
Pull out the 2x minus 3. And I see that y is equal to 2x minus 3 times my x squared minus 6, which is nothing more than x minus root 6 times x plus root 6. Is that not true? Who that cares? Why?
That's where it crosses
Uh,
the SS.
Those are zeros.
Nice. These are zeros of function which will give us location of the x-intercepts. And so I think, graphically speaking, oh, I hate to erase it, sorry.
You decapitated my.
I did, I'm so sorry.
No, you're not.
It wasn't intentional.
You keep doing it.
It's better than mine. So I think, graphically speaking, here is the x-axis, here is the y-axis. My x-intercepts are located at, I don't know, is it at negative root 6? But you know, root 6 is somewhere between root 4 and root 3. Excuse me, between root 4 and root 9. Somewhere between 2 and 3. But I think that 1.5 is to the left of it. So I think here's the location of positive root 6 comma 0. I think by factoring that polynomial expression, I've identified the location of the x-intercepts. And I think those x-intercepts have 3 zeros of those linear factors that subdivide the real number line into 4 sub-intervals, and here they are. And I think I can test these 4 sub-intervals to see what the sign of the y values is. So let's test it. If x is a billion, plug in billion for x here, here, and here. Is it not true that all 3 factors are positive?
Yes.
Yes.
And so the product's going to be.
Positive.
Now choosing a value for x in here
Nothing.
I'm wasting time on the clock.
It's just negative.
I think this 0 right here is a 0 of a linear factor. Whoops, over here, raised to an odd power. I'm going to get a sign change. Actually, I'll stop. I think each and every one of these real numbers is a 0 of a linear factor raised to an odd power. I think each and every one of them is going to act as a toggle switch. I get a sign change everywhere.
Is that true for all odd powers?
Yes, even if that were 3 or 5 or 7, it's still true.
But if, let's say, 2x minus 3 was raised to the, was squared,
Then I think about this 0, I would not get a sign change,
oh,
but it
it
would
would
be
just be
negative.
a negative.
Do you see why?
Yeah, I remember from pre-cal.
Right?
I'm kinda confused, what is the rule for when it, totals like that?
Here's a rule.
But that-
Do you not agree that this is a 0 of this linear factor?
Yes.
And so I think for a value of x that's really, really close to root 6, the value of this and this is not going to change. But if I got a value just slightly bigger than root 6, I think this is positive. Something a little bit bigger than root 6 minus root 6 is positive. But something just a slightly less than root 6 in for x is going to give me a negative value. And so I think when this linear factor is raised to an odd power like 1 or 3 or 5 or 7, I get a sign change on either side of that particular 0. Shoot, you guys, I'm just losing track of what I'm doing. Does this mean I'm concave down, or does it mean I'm decreasing? Neither. This means
That it's positive or
the
negative.
y values are
Or negative.
negative, which means I live
Below
below
the
the x-axis
x-axis.
direction my point. You see why I'm being so careful in labeling my number line? This is a sign graph for y's. Let's do it for y prime. To compute y prime. Oh shoot, this is polynomial. That should be a piece of cake. I said that should be a piece of cake.
6x squared minus 6x minus 12.
X squared.
X squared minus
Did you say
x
cold?
squared minus.
Plus.
X. Wait, why is it?
Squared. X minus 2.
Oh, okay.
Thank you.
So he.
So if I build a sign graph for the first derivative function, oh, here I go again. I'll plot the zeros, those two linear factors, which are -1 and +2. Those two real number lines subdivide the number. Sorry, those two real numbers, subdivide the real number line into 3 subintervals. If I plug a billion in for x, positive, 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 done. Oh, but shoot. These are zeros of linear factors raised to an odd power.
Negative.
Above the x-axis?
No, that means
No,
that the
means
slope is increasing.
Yeah, to say that y prime is positive over this interval really means about the original function y is that it's increasing, and then it's
Decreasing.
and then it's
Increasing.
increasing. Do you think this value of x necessarily yields a local max?
Yes.
I think the answer is yes, because it's originally a polynomial function. So no matter what I plug in for x, the y values are defined. And so I think for free, negative 1's a local max, and I misspoke. I said negative 1's a local max. I meant to say negative 1 yields a local max, and positive 2 yields a local min. As a matter of fact, since I'm on a roll, let me take a break and compute the second derivative function. I think y double prime is nothing more than or shall we say 6 times
X minus 1. Or 2x minus 1.
which means if I build a sign graph of the second derivative function, plot the only one 0, which is positive 1/2. Let's test. If x is a billion, oh, piece of cake, that's positive. It's just that on the other side, I'm going to change signs because this linear factor is being raised to an odd power. So help me. Does this mean I live below the x-axis or I'm decreasing? Neither. It means I am. It means the original function is concave down as opposed to
Concave up.
concave up on the other side of 1/2. I guess 1/2 comma whatever is going to yield a inflection point. And to find the whatever, I plug 1/2 in for x here.
Nope.
No, I really meant over here.
Nope.
No, the original one to find the corresponding y value. I think putting things together, I think we have enough information. I think negative 1 yields a local max, so you guys, let's take a minute. Let's find out what the corresponding y value is when x is negative 1. I can't read my writing, I think I've erased it. To find the corresponding y value? Is that a negative 2?
No, yeah, negative 2.
Excuse me? When x is negative 1, is that a negative 2?
No, it's positive.
It's positive 5, I think, for the entire thing if you plug negative. Or no,
Maybe
positive
so.
1.
I'm just saying when I plug
No,
negative
it's
1
only
for x
positive
here,
1.
is that a
Never mind.
negative 2?
Yes.
Yeah.
Thank you. Minus 3 is negative 5.
Yeah. No, I'm wrong.
Plus 12 is 7.
Yeah.
Plus 18 is 25.
Yeah.
You guys double check me if I'm wrong with my arithmetic. But negative 1 comma 25 is roughly speaking right here. If x is equal to positive 2, where I got a local min, I'm serious, I have no idea what the y value is. Does that give me a 16? Minus a 12? Minus a 24 plus 18? But that gives me positive 4, that gives me negative 20. Doesn't it give me like a negative 2? Tell me if I'm wrong. Okay. But I come up with 2 comma negative 2. And I think as far as the inflection point is concerned, when x is equal to 1/2, I have no idea what the y value is. If x is equal to 1/2, doesn't that give me 1/4? Minus 3/4? Minus 6 plus 18? But that gives me a negative 1/2. And this gives me a positive 12. So is that an 11 halves? So I think when x is equal to positive 1/2, the y value is going to be, I've lost it. Did I say 11 halves?
Well, it's 23 halves, but yeah.
Same thing, isn't it?
Yeah.
Let's put everything together. I think to the left of this x-intercept, my y values are all negative, but my slopes are all positive. I'm increasing. And I'm concave down. I think I have to do something like this. My y values are all negative, I'm increasing, and I'm concave down. In fact, I stay concave down to that local max. And all of a sudden after that, I become decreasing, but I still maintain downward concavity up to x equals 1/2. As a matter of fact, I pass through the y-axis, pass through that inflection point, but all of a sudden after that inflection point, I become concave up. not only am I concave up, but I pass through this x-intercept, I hit this local min. But after that local min, I become increasing, but I stay concave up until I hit this x-intercept and I pass through there. I'm still increasing, still concave up. I'm just positive with my y-values. Whoa. Oh, you know what, you guys? I'm serious. I missed something. I really did. Where did I cross the y-axis?
18.
Where did you go so fast?
Equal to 0.
Because I plug 0 in for x, and what do I get? A headache. I'd rather just go right up here. It's easier. I agree. You know I can't draw very well, but I think that's a fairly decent representation of graph because I've labeled all the interesting points. I've labeled intercepts, I've labeled local extrema, and I've labeled the inflection point. Are you there?
Yeah.
But we forgot to state where it's increasing.
You know, I could ask you the additional question, over what intervals is this function increasing? You would say from negative infinity to
Negative 1.
negative 1 stop. Do you include negative 1 or not? Bracket. You do include it, yes. It's also increasing over the interval from 2 to infinity. Do you include 2, yes or no?
Yes.
Yes. Over what interval is my concave up?
Negative infinity.
1/2 on up. Do you want to include 1/2 or not? No. No, I agree.
Because it's neither. Good. Now, why are we... Okay, never mind, I remember. I was going to ask why are we including 2 there and not there, but I remember the answer to that question for me.
Question. Give me everything. Graph the darn beast. Give me intercepts, asymptotes, local extrema, inflection points, discuss increasingness, decreasingness, and discuss concavity. Well, first things first, you guys. Asymptotes that.
Negative 1.
Where else? Where else? I'll close my pen, it's drying out.
2.
What's 0?
Y.
Thank you. So you're saying y equals 0 is a horizontal asymptote. How do you know that?
Because the degree of what your x is raised to is equal. Or
It's less than on the
it's
bottom.
less than equal.
So the degree upstairs is less than the degree downstairs, so you guys learned back in pre-calculus that you get a horizontal asymptote for free at y equals 0. Why?
That's a better question.
It is.
Is the degree on the top equals the degree on the bottom?
No, it doesn't.
No, it's better.
The degree on the bottom is bigger, so any number you plug in it will be approaching 0 because all the numbers are getting like 1/32.
Oh, yeah.
You know what? You're right. It just still sounds to me as more like some Harry Potter hand waving.
It's approaching 0 because all the numbers, like the denominator is getting bigger. as you
Approaching 0 when?
add-
When x is
Increasing.
increasing how far? How far?
To infinity.
Nice. Can I prove to you what you're saying is true? So what you're really saying is if you took the limit as x increases without bound of x minus 2 over an x squared plus 2x plus 1, if you multiply top and bottom by 1 over, how about x to the highest power you see downstairs? We did this earlier this semester. I think you end up with a limit as x increases without bound of 1 over x minus 2 over x squared all over 1 plus 2 over x plus 1 over x squared. It's just that in evaluating this limit, you and I recognize that this particular term goes to 0. So does this one, so does this one, so does this one. And so I think in the end, all I'm really left with is 0 divided by
1,
which is
0.
That's why when the degree upstairs is strictly less than downstairs, you get a horizontal asymptote for free at y equals 0. Can I erase that? That's a little business.
So anytime we want to check that, we just do limit if x is goes to
If you want to
infinity.
verify that what your math 29 professor said, yes.
Okay.
Yes, sir.
But then if you set y equals to 0, would you not get an x-intercept?
Well, that's true, but I think it's a completely different question. I was trying to ascertain, is there a horizontal asymptote?
But if there is a horizontal asymptote at 0, it means that it never crosses the x-axis.
Whoa, what an important question. If I've got a function that has a vertical asymptote, I can never cross it because when I cross it, I have to bend back towards it and tend towards it, which means I violate the vertical line test. So the graph of function can never cross a vertical asymptote, but the graph of function can always cross a horizontal or an oblique asymptote at finite values of x. It does not violate my definition of the function. So you brought up a really good point. I got a horizontal asymptote at y equals 0, but I've also got some x-intercepts. I do cross that horizontal asymptote at finite values of x. It's just at extreme values of x, like infinity to negative infinity, then I got to start cutting it like a magnet, like an electric magnet, and not touch it.
This is kind of off topic. I was just thinking about the final exam, and would you put a question where we would have to go back and take derivatives using the limit?
Oh, yeah.
Okay.
Oh, yeah.
Just checking.
Oh, yeah.
Oh, well, I thought maybe we'd leave it up there.
No. Ryan?
What causes certain equations to like go above the vertical asymptote and then, the horizontal asymptote and then like kind of come back and hug it? You know what I'm talking about?
I do.
What
It-
causes, what causes that?
And this is a perfect example.
Okay.
It's a perfect example where I think at a glance, you and I can say to ourselves, well, jeepers, when I plug 2 in for x, the whole fraction is 0. So that's the location of x-intercept. So I got an x-intercept of 2, 0, but also I got a horizontal asymptote of y equals 0 because the degree upstairs is strictly less than the degree downstairs in terms of polynomials. I think that's what tells you that you cross a horizontal asymptote. Is that number 1, I've got an x-intercept, number 2, I've got a horizontal asymptote on the x-axis. I think that's a dead giveaway.
Okay.
You guys, let's put this together. Actually, I misspoke. Let's not put this together. I don't have a lot of separate things yet. But for now, graphically speaking, let's see what I can say about the graph of this function, this rational function, because it's a ratio of 2 polynomials, without using any of my calculus tools. And with no calculus tools, here's the x-axis. Here's the y-axis. I expect you guys knew before you walked into this classroom before the semester that you would say the 0 by numerator yields a
2.
location
X equals
of my
2.
x-intercept. The 0 by denominator yields the location of my vertical asymptote. Now I know this was hand-waving in Math 29 or your pre-calculus or your college trick class, but somebody said, well, if the degree upstairs of the polynomial is less than the degree downstairs of the polynomial, you get a horizontal asymptote for free y equals 0, but we've justified it with our tools of calculus.
Is that x equal
Negative 2?
Oh, thank you very much. I agree completely. My goodness. Oh shoot, what have I just done? I found the vertical asymptotes. I found the non-vertical asymptote. I found the x-intercept. What's the y-intercept?
Set x equal to 0, so
So I put 0 for x, what do I get?
Negative 2?
-2, yeah.
So I think 0, -2 is the location of the y-intercept. Next, let me build a sign graph for y. And to build a sign graph on this number line, I will plot the 0 in my numerator and the single 0 in my denominator. And I'm too tired, I'm not going to finish. I get to cheat. I think when x is 0, I already found the y value to be negative. And 0 for x is in between here. So question, is that the 0 of a linear factor raised to an odd power?
Yes.
You bet, sign change. Is that the 0 of a linear factor raised to an odd power?
No.
No, so nice, no sign change. I built my sign graph so quickly. I think to compute my first derivative function, oh, I've got room over here, I'll steal it. To compute y prime, I will use the Cauchy rule. I get what the heck is downstairs, as is do not touch, times derivative what's upstairs,
1.
minus what's upstairs, times derivative what's downstairs. All over downstairs twice. You guys willing to expand this for me?
Nope.
No, you shouldn't be willing. Just factor it out. And one of those factors on the outside cancels with one downstairs. And when I pull out a factor of x plus 1 upstairs and cancel with downstairs, I think what the heck is left over is an x plus 1 minus a 2 times x minus 2. Or shall I say, is that a negative x? Is that a plus 5? Ugh, I can only do it. Yes.
Now, for the x plus 1 squared, you took the derivative of that, and I understand that in this circumstance it would end up being 1 and not matter, but don't you have to use the chain rule?
You're right. I do have to multiply by the derivative with respect to x of the inside.
But it would be
It's
1.
just that ends up being positive 1.
But you still have to do that, right?
Yes, in my head I did just that. That is what I did. By the way, building a sine graph for the first derivative function, I guess this means that plotting the 0 of my numerator and my denominator, I can test. Plugging a billion in for x, positive, negative, here it is. It's just that both these numbers, 5 and negative 1, are zeros of linear factors raised to an odd power. I know I get toggle switches all over the place. I change signs. But that means I change from being decreasing to increasing to decreasing. Do you guys all agree? All agree. This means I got a local min? Or actually, I made a mistake. Is this local min or local max? Which one? Which one?
Neither.
Neither.
Oh.
So did I say it was negative 1? My original function is not even defined.
Yeah, it's
It just means about a vertical asymptote. I change from decreasing to increasing. I do, however, think, since 5 is in the domain of my original function, this doesn't yield a local max. Let's find it. When x is equal to 5, what is the corresponding y value? Is it 3 over 6 squared?
Yep.
Which is 3 over 36, which is 1 over,
12.
yes, 12. And so when x is equal to 5, the corresponding y value is 112. Actually, you know what? I should exaggerate it. I should put it a little higher. I don't care if I'm off scale. I mean 5, 112. However, if I try to find inflection points or where my function is changing concavity, I will compute my second derivative function. And to compute the second derivative function, let me use this version of the first derivative function. I think that gives me the second derivative is what's downstairs as is. Times derivative of top. Minus what's up top. Times derivative of bottom. All over what's downstairs. Squared. Okay, you guys, what's your technique for using a broom to clean this up? Factor out an x plus 1 squared. Cancel with it 2 of them downstairs. You're left with 4 downstairs. But I think what the heck is left over upstairs is a negative x plus 1 factor minus a 3 times negative x plus 5. But I think that's nothing more than a positive 2x minus 16 over x plus 1 to the 4th. Or shall I say 2 times x minus 8 over x plus 1 to the 4th. Now building a sine graph of the second derivative function. Doesn't that mean if I plot these two zeros of negative 1 and positive 8, I can test? Let's test. If x is a right of 8, like at a billion, positive, positive, positive. However, 8 is the 0 of a linear factor raised to an odd power. I get a
Negative.
But negative 1 is 0 of a linear factor raised to an even power, so I
Same
don't
sign.
get a sign change. Help me. Is it decreasing, or I'm below the x-axis? Neither. Concave.
Down.
Down. Concave.
Down.
Down. Concave.
Up.
I agree. Let's put it all together. So putting all together, I am to the left of this vertical asymptote. I'm above the x-axis. I'm decreasing. And I'm concave down. So I'm above the x-axis. I'm decreasing.
How does that work?
Is that really true?
I thought they would be at the bottom of the, doing the
Negative.
thing.
Let me go ahead and ask Wolf.
Negative 2.
No, I'm serious. I'm kind of perplexed. The sine graph for the function, the original function, says I'm above the x-axis. When x is negative,
I think we broke that.
I don't think I agree with that. I think there's something wrong with the sine graph. Can we just double check it? I mean, if x is between 0 and 1, I already found the y value to be negative, and I put a plus sign there. Did you guys see that?
Yeah.
So I'm not going to change anything dramatically, but I do disagree with the sign graph. Look, between negative 1 and 2 is 0. I found the y value to be negative. So I think, with my green pen, I think this should be negative. It's just that this 2 is a 0 of a linear factor raised to non-power. Like I said before, I do think I get a sign change, but that makes it positive. I'll use green so you can see where my mistake was. I think this is 0 of a linear factor raised to an even power. I think I don't change signs in that sign. So I apologize. I hope I didn't make any other silly arithmetic errors.
Oh, so where you messed up is just our test point?
Yeah, actually, I didn't mess up at the test point. I said when x is 0, the y value was negative. I just put a plus sign in there.
Oh, okay.
Well, let's see if I can put things together with my purple pen. Let's see. To the left of this vertical asymptote, my y values are all negative. I have to abide by these two asymptotes. I'm decreasing, and I'm concave down. So don't I have to look something like this? Hugging the asymptote?
Nope.
What do you mean no? Why not?
Because there's no x-intercept.
Number 1, I didn't find an x-intercept. Number 2, I violated the first sign graph. I'm supposed to be below the x-axis to the left of the vertical asymptote. Number 3, I'm supposed to be decreasing. Whoops, it's not. Number 4, I'm supposed to be strictly concave down. Whoops, I'm not. I'm concave up. I think I'm horribly wrong. So I think to fix my mistake, abiding by both the vertical and horizontal asymptote, I have to be hugging them. I have to be below the x-axis according to my first sign graph. I have to be strictly decreasing according to my second sign graph, and I have to be concave down according to my third sign graph. However, to the right of the vertical asymptote, am I above or below the x-axis?
Oh, wait.
I'm below my negative sign in green. So I've got to be hugging this vertical asymptote down here.
Yep.
Actually, my second sign graph says I'm increasing. My third sign graph says I'm concave down. I pass through this y-intercept, hit this x-intercept, hit this local max, but after which I'm going to be decreasing and still concave down up until I hit the point whose x-coordinate is positive 8, and then I'm concave up and hug that horizontal asymptote. I think that's what I have to look like.
What does Wolfram say?
What does Wolfram say?
Wolfram agrees.
Wolfram agrees.
It's not a he, is it? Isn't it an it?
It's made by a guy named Wolfram.
Is it really?
Yeah.
I don't know his name.
I never use it. I never go there.
Well, it helps if your brain is Wolfram. I mean, I've always seen a Wolfram.
So you guys, you happy with my picture? All right.
I just wanna add,
No jerks, no jerks. I'm sorry.
just really quick, what's that one way up in the corner? That term, 3x plus 1?
You mean up here?
Yeah.
3 open parentheses, x plus 1 closed parentheses squared.
Oh, okay, sweet, thank you.
Aren't you glad I take your exams? You guys, I messed up. What's the purple question mark? Or how do I find it? Plug it back in the original question. What if I don't? What about jeepers? I'm beating that clock. Third example. What about a function like this? You know, I think this example's a little different. I think before you and I get started, we should set some ground rules when it comes to sketching the graph of this function.
X can't be negative.
X greater than 0 or equal,
X greater than,
or equal to 0.
X greater than.
Oh,
Negative 1, negative 1. So I think the domain of this function is all real values of x that are greater than equal to negative 1. Actually, is negative 1 in the domain itself?
Yes.
Yeah.
It is, because when I plug negative 1 for x, I get the square root of 0, which is another real number, it's just 0. So I think negative 1's okay. But keep in mind, x cannot be less than negative 1. Well, do you think you guys can take a peek at the output of my function over there and just rattle off at the tip of your tongue what the x-intercepts are? Negative 1 and
0.
So we really mean negative 1 comma 0 and 0 comma 0. Good. And let me graph x-axis, y-axis. I think at negative 1 comma 0 and at 0 comma 0, I've got 2 x-intercepts. How do you find the y-intercept? Are you graphing it before? I do.
I am. It looks nasty.
Nothing is nasty.
Sorry, it's elegant.
Thank you.
Apologize.
I agree with that.
It's complex.
Complex.
It's interesting.
Complex doesn't mean bad.
Complex doesn't
True.
mean pretty either.
What does mean what?
Doesn't mean pretty either. I mean,
Oh, I associate complex with pretty. Anyway, how do you find the y-intercept? You plug 0 for x, but what if you don't? For free is what it makes sense. Got lucky. Do you think I have any vertical asymptotes?
No.
No, it's not a rational function. Or shall I say, I'm not dividing by 0. What do you think about horizontal asymptotes? Why not? You're right. But how do you know?
It's not polynomial.
Because I think when you take the limit of this, as this goes to negative infinity, you're out of luck. Because the domain stops at negative 1, not anything to the left. I think when you take the limit of this as x approaches positive infinity, this increases that bound, neglecting the other part. So I'm still out of luck. So I really do think I have no horizontal asymptotes. So I guess the next best thing is to build a sign graph. In building a sign graph, let's see when the y values are positive and negative. I'll plot the 2 zeros of my function, which are negative 1 and 0, and let's test. If x is a billion, isn't everything here positive? But if x is negative 1/2, that's positive, I guess it's positive. And if I plug negative the billion in for x, I get
Nothing.
good, because it's not the domain of my function, so who the heck cares? Do you guys agree?
Yep.
So my next step is to differentiate, to find out when I'm increasing and decreasing. And to differentiate, I have to use the product rule. And in using the product rule, I've got the first times the derivative of the second plus the second.
You forgot the x squared.
Oh, thank you. I said the first times the derivative of the second plus the second times the derivative of the first. And finding common denominator, which is 2 root x plus 1, wouldn't that just simply give me an x squared plus, I don't know, is that a 4x, x plus 1?
Yes.
Or shall I say, is that a 5x squared plus 4x, all over stuff? Or shall I say, that's an x times 5x plus 4 over stuff? And to build a sign graph, would I not naturally plot on this real number line the zeros of my denominator and the zeros of my numerator? And test. If x is a billion, piece of cake, everything positive. But if x is something like negative 0.0000001, that's positive.
still positive.
Positive. Negative, if x is negative 0.00001. And finally, if x is really, really close to negative 1, that's still positive. But if x is really close to negative 1, this is really close to negative 5. But that's negative 5 plus 4, which is negative. But that's negative. I think it makes it positive.
So there's no toggle switch in a situation like that.
Correct, because I got the security function there. And if x is negative 7, plugging negative 7 for x, what do we get up here? It doesn't matter, because downstairs I'm not defined. So who cares?
I'm sorry, I kind of lost you. Where did you get negative 4 over 5? Did you plug in 0 for x?
Quite the contrary. I set this particular factor equal to 0.
Okay.
And if I set my 5x plus 4 equal to 0,
Oh, well, why are you doing that?
because I'm trying to find the zeros of my numerator. I'm trying to find critical numbers.
Oh,
And I think critical numbers are simply numbers for which my first derivative function is equal to 0 or undefined. So I just set that one factor equal to 0, and I solve for x. That's all I did, nothing more.
And since we already have zero, we neglect the other zero up there.
I agree, it was just for free. So everybody, do we all agree that to the left of -4/5, my function was above the x-axis?
No, it's increasing.
Actually, yes, but not because of that reason. I think this says I'm increasing. And then, decreasing, then,
Increasing.
do you think this yields a local max?
Yes.
Why?
Because it's
Why not? Actually, that's a good response. Why not? Because, when I plug -4/5 in for x, my function is defined. Actually, my function is defined for all values of x bigger than -1, so I think necessarily that yields a local max. This yields a local min. Do you mind if I plug it in real quick? If I plug -4/5 in for x, I have no idea what I get. 16 25ths, 16 over 25 root 5? I said 16 over 25 root 5 if x is
What are we plugging in?
-4/5.
-4/5.
You double check my arithmetic.
Absolutely.
Thank you.
Yep.
I appreciate it, David. You're hard work. Oh no, I can't finish. Darn it. I didn't find inflection points. So, you don't have to exaggerate. If I give you the second derivative function, I'm just going to take my first derivative function and differentiate again. Oh, can I take this version? It looks nice. Oh, you guys, I misspoke. Can I take that back? Do you mind if I take this version instead? I think it'd be a little easier. Instead of my dotted black box. Let's differentiate. And in differentiating, I get my denominator as is, as 2 root stuff. Times the derivative of my numerator, which would be 10x plus 4? 10x plus 4. Minus my numerator as is, that would be a 5x squared plus 4x. Times the derivative of my denominator, which would be 1 over root x plus 1. All over what's downstairs.